This is a tutorial for the electroscope simulation for, in Ontario at least, grade 9 electricity. And so when you load it up, you got this electroscope. There's a transparent option here. You can make it not transparent, but I wouldn't. It looks kind of neat, but there is a bit of a delay between when the leaves respond because of the way I programmed the simulation. So the way this works is that if your rod is in its little house here, it will not affect the electrons inside the electroscope. And if you give it a positive charge, you can give it small charges, but you might as well just crank it all the way up to 100. If you give it a positive charge while it's in the house, it won't impact anything, but as soon as it moves out, you can see it's pulling those electrons. If you find that effect too much, you can, of course, reduce the amount of charge so it has a weaker effect on them. So there's our induced charge separation, and then the leaves separate. Okay, and likewise, you could give it a strong negative charge. You can actually push them down. If you find the electrons are in weird places, you can just hit reset and start again from the beginning. Give it a strong negative charge, and it will push those electrons out of the way. If you want to do charging by contact, you just touch those two circles together, and you want to let 90 or 100 electrons go in to really have a really, really strong impact there. Likewise, actually, why don't I show you grounding? If you want to ground it, you just connect the ground to it, and it will take all those extra electrons. The thing here is that it does take a little bit of time. It's not instantaneous. Of course, in real life, those leaves will drop immediately, but in my simulation, it just doesn't work that way. So you give it some time, though, you do see the leaves will drop. Okay, and I don't know if it goes exactly to 0, but it will get pretty close. So there you go. Once you're ready to reset, you just reset. If you want to charge by contact with a positive rod, same thing. You just make it positive and touch it on there, and a lot of the electrons will just move into the rod. And I put the rod back at its home, and you can see the whole thing's got a positive charge, and the leaves are separated. And again, if you want to ground it, you just drag it on there, and those electrons will come back in. And eventually those leaves will drop again. But it can take a few seconds. And that's why if you're not on transparent mode, sometimes it just looks like nothing's happening for a few seconds. So there we go. And then the last version, you can see sometimes it's not perfect. It only gets to about 10 or 9, but that's best I could do for now. The last version is charging by induction. So we can give it a positive rod and move it there, and then you can have that the electrons be pulled out of the ground. Now, this does take a little bit of time, although the simulation is running slower than it normally would because my computer is taxed and it's overheating. But you want to let it get to, let's say, at least -70 or -80. When you are doing this, it will not take this long. I think it's because I'm doing a recording of my screen at the same time. Regardless, once you're there, you can disconnect the ground and put the rod back in its home. And you can let those negative charges spread out. They will dip momentarily as they're neutral, but then they'll spread out once more afterwards. So there you go. Likewise, we can charge, I'll just reset it, we can charge negatively with induction by pushing those electrons out. I guess this is a little faster. You can even move it around and really force those electrons out by moving the rod around. And then remove the ground and replace the rod into its home. And now we've got charging by induction and giving the electroscope a positive charge. I hope you enjoyed the simulation. Hope you find it useful.